I think it's strongly coupled with that. So it feels reasonable that LLMs should be able to be creative in the same way.
If I may, one favorite trend, at least that I'm seeing, is that yes, reasoning should be added to LLMs. But if we take the latest kind of image generators that we have, like Sora or Stable Diffusion version 3 or whatnot, what they're doing is, I would say, reasoning, but in latent space. And Janne could also say some similar stuff, but what we're actually not seeing that for text models or for text generation. And the reason potentially for that is that for text is actually rather high level of abstraction already. But pixels are not, or audio time samples are not. And they are very high dimensional. So it doesn't work to do it in sensor space, if we call it that, I would argue. So you can't do reasoning or generation in sensor space for images and audio, but you can for text potentially. But if you take like Sora and I guess Stable Diffusion, etc., they basically have an autoencoder first, a variational autoencoder, and then they use a diffusion transformer inside it, and you do the like 50 steps or 100 steps of diffusion in the latent space. And this is a very attractive idea to me, and I think the same should apply to text. I think we should stop doing all the next token generation in text space, and move it to latent space as well, and do the reasoning in latent space. Do you think that's the direction we are heading?
Yeah, what does the reasoning look like then? I think we need to go into that as well with the JEPA architecture, where you have some kind of energy function, and you would try to the energy function would need to know what is a more clever answer.
The JEPA, if we go to that, it stands for Joint Embedding Prediction Architecture. It basically means that instead of predicting from X to Y, you do an embedding, a joint embedding of both X and Y first. So you have an embedding of the sensory data that you do see, which can be text, audio, or images or whatnot. And then in that embedding space, you do some prediction. And that's a prediction architecture. And for doing that, they have a number of things. You have the perception part, which is basically the embedding part. Then they have a world model, trying to understand what is the way the model works. So given an action in current state, what would the next step potentially be? So that's kind of a world model in some way. You have some kind of actor to say what action should I take in this certain state that you have. And then you can basically do some kind of search in that space and saying, okay, I have this kind of perception of X and Y. I want to make them as similar as possible, minimize the energy between them. How can I make that happen? Well, I take an action from X. I see what kind of latent representation I end up with, and you use the world model to understand that, and you continue to search through in the latent space to find a minimal energy between the X and Y. So for me, this is a very attractive idea, and I think that would be so much more efficient than having to do the encoding, decoding all the time for every bloody token that you have.
I don't think that necessarily it's the latent space thing that is the make or break. So one reason to believe that this is a good approach otherwise is that, alpha mu, which has its sort of dynamics. Mu zero, sorry. Yes. That has the dynamics simulator and does everything in pure latent space is cool. Yes. We know, for example, that it converges much more slowly. So even learning tic-tac-toe is very difficult until it doesn't, and so forth. But it's a good approach. However, I think that the middle layers of the language model are still doing the same kind of search. The only problem is, and I don't think it's in sort of fine-grained token space. I think it's in abstract token space that doesn't mean anything. And the main problem is it's not allowed to go back and think for as long as it feels like it should think for.
You can't retract either.
Yeah, it's first token is done, you're committed. And it's the same thing sort of with the diffusion model where, you've thought for 50 steps and then you're committed. Yes. You have to keep going. So it feels like there needs to be a separate component like the value network or something that's allowed to...
Because the JEPA has the cost function as well.
Yeah.
And that is basically what you're saying. So you can retract. So you can take some actions.
Yeah.
You evaluate the cost. And that's a separate part of the brain, so to speak.
Yeah.
And then if it actually goes down, you can actually retract and do some kind of proper, like Monte Carlo kind of research.
But it's not intuitive to most people that the difference between guessing what the next best move is and the difference between predicting what the likelihood of winning is so significant in the performance characteristics of the resulting model. And that value network that is trained on likelihood of winning rather than next best move is so significant in improving its performance. So the question here is, how do we set this value network, or whatever we want to call it, how do we set the goal to the right goal so that it converges well, performs well, and all that kind of stuff? That is the million-dollar question, isn't it?
Yeah.
I guess they have the world model there in some way. This is the value,
Because it would be attractive to just have like a delete token when you're generating tokens,
right.
and then you just go
no
back.
one done that,
Yes, but then what is a good indication that you should actually delete?
But I guess the reflection tuning that we started with is a way to do that, saying you should retract what you just said in the thinking phase, and now try to come up with another thing. So it is kind of a retraction possibility.
Doesn't that remind you of like a Turing machine, a tape machine that goes back and sort of goes over its own code?
But it can't really erase it. It just says skip that part and continue to generate on the tape without moving to the left, so to speak.
Many people in the audience might not know that the N and NP is not non-polynomial, it's non-deterministic polynomial, which means that this tape machine, if you can imagine a multi-dimensional, multi-world tape machine going in every direction, is actually like a tree or a graph, which is what the Monte Carlo search is a little bit like.
Anyway, super fun stuff and hard to know what will happen here.
Here's a question.
Okay.
Is it the haves and the have-nots? Are we just here relegated to watching what happens and musing at it? Or are there things that we can do? I'm just very impressed by all the thirsty guys on Reddit that are making RPG fine-tunes and super advanced quantization things. I do feel like they've contributed, maybe not 50%, but 30% to the sort of the breakthroughs of the past 6 months. Are people still in the game? Is Mistral still in the game? Or is there anything for people like us to do?